Okay, today what we're talking about is equidistance theorems. The first thing I want to talk about is the definition of distance. Distance is the shortest distance between 2 points. So if I have these 2 points, the shortest distance between them, that will be the distance between those 2 points. A line segment is the shortest path between the 2 points. So for example, if I have RS, that line segment would be the distance between those 2 points and also the shortest path. Here, if I have PX and XQ, and I know that PX is congruent to XQ, what that's saying is that P is the same distance from X as Q is from X. Let's just put numbers with it. If I say that this is 8 and this is 8, what I'm saying is that P is 8 units away from X and Q is 8 units away from X. Whenever you have 2 points that are both the same distance away from, in this case, X, those points are called equidistant. Okay, we've done a lot of different problems that had pictures like that. If you can't see them on the video, go ahead and look in your book in lesson 4.4 and it'll have better pictures in there for you to see. We've done a lot of problems where we knew those were congruent and those were congruent, or these were congruent and those were congruent, those are congruent and those are congruent. We've done a lot of different problems that have those 2 sets of congruent sides, and we usually did a detour to prove that maybe this third side was congruent, or maybe this angle was congruent to that angle. Well, in each of these cases, C and D are both equidistant from A. C and D are both equidistant from B. They're the same distance from both of those points. C and D are both equidistant from A, and C and D are equidistant from B. Here, C and D are equidistant from A, and C and D are equidistant from B. So there's just a couple of examples of where we've already been using this, we just didn't know it yet. Okay, now let's talk about a perpendicular bisector. Just like how the name sounds, if I have a perpendicular bisector, the perpendicular bisector is both perpendicular and bisects that side. We're going to use equidistant and we're going to use perpendicular bisectors. The 2 shortcuts that I want you to write down in your notes is here, 2 points, equidistant implies you have a perpendicular bisector. And anytime you have a point on a perpendicular bisector, that implies you have congruent segments. So I'll let you guys write these down and then we'll talk about both of them. Okay, to talk about the first one, 2 points equidistant. Implies perpendicular bisector. If I go back to one of those examples that we've already had, if I know that B is equidistant, A is equidistant here and here, and I know that these are congruent as well. So I've got 2 points that are equidistant. I know that A and C are both equidistant from B, and I know that A and C are both equidistant from D. Since I know that I've got 2 points that are equidistant from this line, A and C are equidistant here because those are the same. A and C are equidistant here because those are the same. Since I know that I've got 2 points that are equidistant, that implies that this, oopsies. That implies that this and this, we have a perpendicular bisector. And our second one, anytime we have a point on a perpendicular bisector, that implies congruent segments. Since I know that this is a perpendicular bisector, any point on the perpendicular bisector is going to give you congruent segments. So this point here and here, those are going to be congruent segments. And if we're going to prove that, I know I've got a right angle, those sides are congruent, that side's congruent by reflexive, so I've got side, angle, side, so CPCTC says those are going to be congruent. If I put another point on the perpendicular bisector and I connect them, then these are going to be congruent. Again, it's going to be side, angle, side, side, right angle, side. If I put another point, these are going to be congruent. Any point on this perpendicular bisector is going to give me congruent segments. Okay, let's look at some examples. So here I know that angle 1 is congruent to angle 2. And I know angle 3 is congruent to angle 4. And I want to prove that I have a perpendicular bisector. Well, the only shortcut that we have that implies perpendicular bisector is the one we just used. 2 points equidistant implies I have perpendicular bisector. So I need to prove I've got 2 points that are the same distance from what our perpendicular bisector is going to be. I know that those are congruent because if I look at triangle ABD, these angles are congruent, so those sides have to be congruent. So I know AB is congruent to AD. Congruent angles implies congruent sides, which means that B and D are both equidistant. I also know that those sides are congruent for the same reason. I know angle 3 is congruent to angle 4, so these sides have to be congruent. Congruent angles implies congruent sides. Now I can say that AE is a perpendicular bisector. Two points, equidistant, implies perpendicular bisector. It wouldn't have mattered if we would have said AE or AC, or if I had another point on there. Okay, that whole thing is your perpendicular bisector. Okay. If I know the triangle ABC is isosceles with base BC, since the base is BC, I know those have to be congruent. E is the midpoint, which means these have to be congruent. If I want to prove that AE is perpendicular to BC, one way that we could do it is I could say, well, this is congruent to itself by reflexive, one step, which means these triangles are congruent by side, side, side. These angles are congruent by CP, CTC. They're also supplemental, which means those have to be right angles, which means that has to be perpendicular. Well, that's 6 steps. I can get it done in 3 steps if I use that I have 2 points that are equidistant. If I have a perpendicular bisector, I'm also going to have lines that are perpendicular. So I'm going to say, well, those are congruent because here, so AB is congruent to AC. Isosceles implies I have 2 congruent sides. I know BE is congruent to EC. Midpoint implies congruent segments, which means that B and C are equidistant from A. B and C are also equidistant from E, so those have to be perpendicular because I have 2 points equidistant, and that implies perpendicular. You can put perpendicular or perpendicular bisector, both would be fine. Okay, the last one I want to look at is if I know AB is congruent to AD and BC is congruent to CD. Since I have 2 points that are equidistant, B and D is equidistant from A, and B and D is equidistant from C. Since I have 2 points that are equidistant, I know that this is going to be a perpendicular bisector. Once I know that that's a perpendicular bisector, any point on that perpendicular bisector is going to give you congruent segments. So the first thing I'm going to do is I'm going to put in my givens, pretend I wrote them down there. I know that that's going to be a perpendicular bisector to BD, again, because I have 2 points that are equidistant. Once I know that this is a perpendicular bisector, any point on here would give me congruent segments. Like what we saw here, any of these points gave me congruent segments, which means that BE is going to be congruent to ED. Any point on a perpendicular bisector implies you have congruent segments. All the stuff is in the book also, so if you guys have any questions on any of it, just go ahead and read lesson 3-4 and do your homework.